Hello, I'm going to talk about a do-it-yourself way of making a CMOS battery for a laptop computer. Most desktop computers, there's a little holder, and you can just take a CS2032 battery, pop it out of this, and put it into the desktop. Laptops, on the other hand, usually have the battery, the CMOS battery, connectorized like this. So the battery is attached to these leads with a connector. These are generally pretty expensive compared to this, so this is kind of a cheap way and easy way to make a replacement for this with just a CR2032 battery. I'm not going to discuss how to remove this from a laptop. There are lots of great videos on how to do that. Normally, I'll just Google the model number of the computer and CMOS battery replacement, and it'll come up with a nice video on how to get to this. And most of the time, it's pretty easy. So I have the materials here that I'm going to use. We have, of course, the removed battery and we're going to reuse the connector and the leads. I have a new CR2032 CMOS battery, some small scissors, some needle nose pliers, electrical tape, and I also have copper tape. And you can use any kind of conductive tape. In the US, you can just buy this in a roll. It has an adhesive backing on it, and then the conductive metallic surface on this side. So once I remove this battery, the first step is to try to remove this heat shrink that's surrounding the battery. And I usually try to start it with my fingernail, and then I use the small scissors to cut it off. And just try to peel it. Now the main thing you want to do is to avoid nicking or cutting the insulation on these wires, but it's really not too hard to get this thing off generally. If you have strong fingers, you probably don't even need the scissors, but so we're just gonna carefully peel this off. Okay. Now, what you'll see is this battery, first of all, has some insulation around there. So that's to prevent contact between the positive side and the negative side of the battery. You can also see there are, it's a little bit hard to see, but there are metallic tabs that are spot welded onto each side of this battery. And this metal tab is then welded to the wire. So we're going to use our needle nose pliers to try to gently remove this tab from the battery. So I usually start by just bending up that tab a little bit on each side. And that gives me something to grab onto with my pliers. So then I take my pliers and I grab a hold of that tab and I just gently twist and pull. And I don't know if you heard that snap, but that was the spot weld breaking off. So I do that on one side and then I'll do it on the other side. Now the main thing you have to be careful about here is just not breaking the weld between the tab and the battery. So you go about it as gently as you can. Okay, so this I can recycle. And now I'm left with the connector, the wires, and these metal tabs. Now in the process of pulling those tabs off, they've gotten a little bent. So I'm going to use my pliers to try to straighten those out. It doesn't have to be perfectly straight, but good enough to make a nice connection with the new battery. Okay, that's not too bad. I'm going to set that aside for the moment. I'm going to pull out my battery, my new battery. Now, one thing you'll want to observe is that there is one side that's labeled positive, and you'll see a plus sign on that. So it's very important to remember that the positive side of the battery is always connected to the red wire. And the negative side of the battery, which is not marked, will be, generally not marked, will be connected to the black wire. And you always want to make sure that there's no connection, no conduction path between the negative side and the positive side. And you'll notice the battery that we removed had this nice piece of plastic around it to help prevent that. I'm going to actually start by making a little insulating barrier on my battery using electrical tape. So I'm going to just cut a small piece of electrical tape. Just a very, very thin strip. Probably 3/8 of an inch or thereabouts. Or, centimeter or so. And I'm going to take it and put it right on the edge and wrap it around. So that's going to give me a little bit of a barrier when I start putting my tabs back on. So you can see it's on partially on the positive side and partially on the negative side, and then I can just trim off the extra here. So this is where I'm going to start making my new connection. To make the new connection, I'm going to use this adhesive copper tape. So I'm going to cut a couple of small squares of this tape, and again, this is roughly a centimeter or so. And so I have two squares, and I'm going to put one on the positive side and one on the negative side. And I'm going to use this tape to attach the tab to the battery. So we'll go ahead and make that connection now. I'm going to start with the positive side, and I'm going to place the tab on the positive side, and I'm going to hold it there while I take my copper tape and peel off the backing. And now I'm going to stick it on and press it down. So you can see I've put the tab down and then the tape over the top. Now, I have a lot of practice doing this. It's a little bit hard to do until you get used to it, to manage to hold the battery and to peel the tape and put it on, but you'll get the hang of it. I want to make sure that there's no touching of that copper tape to the negative side, and I can confirm that there's not. So then I'm going to do the same thing on the negative side. Again, I'm going to place my tab here, and I try to offset the red wire and the black wire a little bit. Instead of putting them right on top of each other, I offset them again just to make sure I don't have any metal-to-metal connection between the positive and negative sides. So I'm going to hold it again. I'm going to take my piece of copper tape and peel off the backing and put it on there. Now again, it's actually extra necessary to inspect this side because the positive side on this battery actually comes all the way around. And I have a little corner here that's looking like it might have contact with the positive side. So I'm going to use my finger and fingernail to make sure there's no connectivity there. And I check my other corners, and those all look pretty good. Okay. So now I've reestablished a connection between the battery and the connectors. Now the final step is using this electrical tape to cover all of this. So I'm going to pull off a piece of electrical tape, and you can kind of experiment with this. I usually use a piece that's probably at least 3 times as big as the diameter of the battery to get a good wrap around. And the main thing you want to focus on here is having any exposed metal covered up. So I put it on, and I stretch it pretty tight, and I just wrap it around. Now I can see a tiny bit of metal here that's still exposed that I didn't completely cover up. So you want to check up here, and you'll also want to check on the bottom side to make sure that's completely covered up. So the bottom here is pretty good, but I do have this little bit up here that worries me. So I'm going to get another little piece of electrical tape and just kind of patch that up. Now, as I tell a lot of people, this isn't beautiful, but it's functional. So I've cut a little piece of tape, and I'm just going to put it around here. Now, a lot of times these batteries are put into a little circular well in the laptop. So I'll trim up the corners a little bit to make the wrapping a little more circular. And want to make sure I don't expose any metal in the course of doing that. Do another little trim up here. Okay, and we're done. So now I have my new CMOS battery, and it's connectorized, and I can go ahead and put it back into my laptop. Now the final thing that I do is, of course, usually the way you know your CMOS battery is dead is that you're getting a report that the date and time is not set properly. So when you put this new CMOS battery in, the first thing you'll need to do is to go into the BIOS or the UEFI and set the date correctly. So that's kind of the signal to the computer that you're telling it, I want you to remember this. So I input the date, I input any other BIOS settings that I want. And to check that my battery is working properly, the next thing I do is unplug the laptop and pull out the battery. I want to make sure that the CMOS battery is actually backing up the BIOS as it's supposed to. So I unplug the laptop adapter, I take out the battery, I let it sit a few minutes, maybe 5 minutes, and then I go ahead and plug it back in and restart it. And if it's remembered the date and the time, then I know that my CMOS battery is performing its function, it's backing up that information, and I've done the replacement properly. If, on the other hand, it comes up and asks for the date and time again, I know that I've made some kind of mistake and I need to check this. And usually for me, the thing that I find is that I may have a slight exposed part of metal, and that's shorting it out, and so it's not remembering the date and the time. But once you do a few of these, you'll definitely get better at it. So that's how you make a laptop CMOS battery out of just a simple desktop CR2032 bare battery with no leads. Thanks for watching.